Hello, today I feel like talking about the internal combustion reciprocating engine. It is a heat engine. Uh, this is just gonna be like a crash course. It's just like just a couple minutes long, so I don't have a lot of time to explain all of it. Just right now, I'll just focus on the four-stroke internal combustion reciprocating engine that runs off of gasoline. There's many other kinds of recips. There's also uh, diesels, and there's two strokes, but I'm not going to get into that just yet. Right now the focus is on the four strokes. Um, the engines that I'm going to bring up, well, basically on this type of engine, um, it can run off of many forms of fuels, and you can use it in many types of vehicles and products. They're not always in vehicles. You can also have them in generators and so forth. There's many types of fuels that they can run off of. Mostly gasoline. Gasoline's the number one source of fuel. Um, and lately, people have been experimenting, and you can already buy cars that run off of natural gas and ethanol, among other things. Previously, all cars ran off of leaded gas. Like every time you go to the gas station, it says regular unleaded. Well, there was a time where all you can buy was leaded fuel. It actually had lead in it, and that's what gave it that quality to prevent it from pre-ignition. And well, when that was phased out, oil companies didn't have a choice, thanks to environmentalists, to push them forward and get rid of the leaded fuel and just actually make high quality gasoline that it didn't have pre-detonation or pre-ignition. And then later on, this was solved using oxygenated fuels. Fuels with an ethanol or methanol blend, but it's rare now to see gasoline and methanol in it because it damages everybody's car. In time, it's corrosive. Methanol is very corrosive. That was another thing. We had buses running around in some major cities that ran off of methanol, and the engines wouldn't last long at all. It was just an experiment, and it just proved that it didn't work. Ethanol was a better choice, though, although you didn't get as much power out of the engines, and you had problems with starting them up in the morning if it was very cold outside. On these types of engines, there's four strokes. It has to go through a complete cycle for every time that there's ignition in the engine. You have intake, where the intake valve opens up, the piston moves on its way down through that combustion chamber in the cylinder, and it sucks in air that's already mixed in with the fuel. You have an air-fuel ratio in there. Most of it's all air. You just have like vapors of fuel in there. Not a whole lot. And the piston works its way back up. It compresses all of that, the fuel and air mixture, to a ratio of typically 9:1 or 1:9. 9:1, and it gets hot. Once it reaches top dead center or past it, that's when the spark plug fires. That's when you get the power stroke. This is what actually makes the transmission turn and makes the wheels turn on the car. It's during that power stroke when a spark plug will fire off, and you get detonation inside the engine. The good kind of detonation. It's a controlled burn. Just go a lot of power. It has the power. The burn, the combustion has no place to go in the container except for pushing the piston down. And while it's doing that, it actually rotates a crankshaft. Next thing you know, the piston goes back up again, while the exhaust valve opens up, and it lets the burned fuel and even the unburned fuel, because there's this pollution in it. It's not 100% efficient. It's exhausted out, and it makes its way out the tailpipe of the car. After that happens, the cycle repeats again. The intake valve opens up. The piston is still on that forward momentum. It rushes down again, and fuel and air gets sucked into the combustion chamber for the next cycle, and it just keeps doing that constantly. Most cars, not all of them, have a tachometer. You could look at the gauge on the dashboard when you're driving. It'll say, per 1,000. So if the number that the needle's pointed at is 3 or 5, that means it's somewhere between 3 to 5,000 revolutions per minute. One revolution is every time that crankshaft makes a complete turn. Just the whole degree, round the clock, complete 360. And that's a lot. And that's a lot to ask something to do. So, it's no surprise that there's going to be a lot of breakdowns. It's not going to last forever. There's a lot of friction in there. The oil itself that lubricates it is acidic, and that eats away at the metal. Every time you do a cold startup in the morning, there's no layer of oil on there. There's usually some, but if the car's been sitting for a while, then there's nothing. It's just metal to metal, and it'll grind for the first few seconds before the oil pump has a chance to actually pump oil through there and lubricate the cylinder walls and the bearing journals and everything. It's very fascinating, just the inner workings of an internal combustion engine. Most notably in this case, reciprocating engines. People study this their whole lives. There's a whole industry behind it.